Hi, my name is Josie Byers. I'm currently a senior at the Community School of Naples, and my invention is Crimson Bloom, which is a novel medium for the upregulation of protogeosin in serratia marcescens D1 as a natural alternative to synthetic dyes, including red number 3. Synthetic dyes are highly prevalent, especially in the food system. A recent North Carolina grocery store study showed that around 30% of their products marketed to children contained red 40, which is the most commonly used artificial food color. Additionally, 96.3% of candy contained some artificial food color, showing how common it's used in these grocery stores. The problem with this is that synthetic dyes, some of them contain benzene, which is a known cancer-causing substance. They could also cause behavioral changes and damage your DNA. I also grew up with a younger brother who experienced ADHD, and whenever he would consume high quantities of red 40 or other synthetic dyes, I could visibly notice a difference in his mood and in his behavior, which kind of influenced me to study this and really see what the other alternatives are to prevent the use of synthetic dyes and shift to possibly more natural ones. And very recently, on January 15th, the FDA banned red number 3. They banned it because of all these negative health impacts, which creates the demand for natural dyes even more greater and even more substantial at this time. Now, natural dyes can be generated in countless different ways, but the one I'm going to focus on right now is that natural dyes can be created through bacteria. There's one specific bacteria known as serratia marcescens, which is commonly used to create this natural dye. Now, it can create natural dye because when it's sampled onto agar plates, it contains protogeosin, which is a red pigment, which can then be used to make these natural dyes. So my engineering goal was to engineer a design to help increase the red pigment production of this bacteria so you can increase the amount of natural dyes that are accessible. Now, I did a preliminary patent search and I looked for keywords including protogeosin and the specific bacteria, serratia marcescens D1, and both of those had pretty limited patents, especially protogeosin only had around 50 to 60 patents using that keyword. So, and after I sifted through all of them, there was nothing regarding upregulating the protogeosin pigment. So it's definitely a novel medium and there's not much on the market like it, which makes this very crucial, especially in this time. Now, for my prototype development, I wanted to focus on the agar plates, which is what's used to put the bacteria onto. So my goal was to try different agar infusions to see if any of them would upregulate the red pigment production. So I infused different combinations of enzymes and gluten into my agar plates. I then added the bacteria. I allowed 48 hours of culture, and I recorded the absorbance, which gave me a quantitative number for the darkness of the red pigment and how much red pigment it was producing. Now, from these pictures, you can see from my first iteration to my third iteration, such a difference in red pigment production. Now, the one on the left looks pretty similar to the control group and what it currently looks like when it's being sampled, and I was able to get it to the photo on the right, which is a very thick and sticky and dark red pigment. So for my results, you can see a lot of varying different colors, a lot of different iterations here. The first thing I noticed when I was inventing this was that the gluten groups worked a lot better than the non-gluten groups. So I definitely maintained the theme of using gluten throughout. Everything in red is that gluten, so you can see typically it has a higher absorbance correlating to a darker red pigment. Some other results is that the enzymes worked better when used in conjunction. So a lot of my groups that had a combination of more enzymes, although the amount of grams of enzyme was the same, it worked better when used in conjunction and not just sticking with that one particular enzyme. And I ran a two-way ANOVA, and my results showed extreme statistical significance, which demonstrates a difference between the control groups and the experimental groups. Also further here, you can see a lot of my groups had a strong difference between them. The market is very large, especially with the recent FDA regulatory change, and current competition is very small, like I said when I was looking through the preliminary patents. And the dye market is large. There are a lot of foods, like that grocery store study, that rely on these natural dyes, making this a great opportunity. Now, to kind of quickly go through the business planning, the first step would be pursuing a method patent followed by a provisional patent, which I am currently pursuing. The step two would be product development, followed by licensing agreements with the FDA, and then market research to assess competitive pricing and the target audience. Now, obviously, I don't have enough time to really go in depth on all of this, especially the startup costs, but here's kind of showing possible projected growth of this product for the next 5 years. Now, liability is super important. I would definitely want to include warning labels, not the product itself, but what it's used for. Handling that bacteria can be very, very risky. So, advise to wear proper PPE, study aseptic technique, clean surfaces, all of that to ensure extreme safety. And for future iterations, I can test different enzymes in the agar. I can experiment with different concentrations. I can infuse proteins. There's a lot that I could possibly do here. Here's my bibliography, and thank you so much for your time.